All right, so now let's implement the solution that we discussed. So now let me just start by declaring a function. So I can just call it as count frequency maybe, right? Like this. And this will accept, an array and the target integer, right? Like this. Now what I can do is I can just capture the length of this particular input array in a variable n, right? And now I can just find the start position of this target integer in this array, right? Like this. So what I can do is I can first of all just say find first. So I'm yet to declare this function find start. I will just declare it in a minute. So it will accept, the input array ARR, the target integer, and also I can just pass the length of the array over here, right? So that I don't have to again and again capture the length of the array while finding the first and the last occurrence of this particular target element, right? So I will just declare this function now to accept these parameters like this. I can just, copy this entire thing like this. And now what I can do is I can just declare the left and the right pointer as we normally do in the case of the binary search, right? This is the standard way of applying binary search. Now I can just run a while loop, right? While my L is less than equal to R, I will just keep calculating my mid, right? So my mid will be L plus R by 2 at any point in time, right? And then I will check if my current element at the mid position is equal to target, right? Now if it is equal to target, I also have to check whether this occurrence of the target integer is also the first occurrence, right? And for doing that, what I can do is I can have another nested if condition, and I can say if my array of mid minus 1, that is the previous element, is not equal to target, right? So if the previous element is not equal to target and the current element is equal to target, then I can very comfortably say that the current element is the first occurrence of the target, right? And in that case, I can just return the mid position, right? Because that is the first occurrence, right? And also I can just handle a corner case over here. So I can definitely check the previous element, but I can only check if the mid element, like the mid pointer, is greater than 0, right? If the mid is equal to 0, that is, it is the first element of the array, then there would be no previous element, right? And then I can just declare this target as the first occurrence itself, right? So my condition should be if my mid is equal to 0, that's the condition I will add, or my previous element is not equal to target. Either of these two will make my target, like the current occurrence at mid, the first occurrence of the target, right? So that's what we are doing over here. And if this is not the case, right, then in the else, I can just, reduce my right pointer to mid minus 1, right? And I can just do binary search on the left half, right? So I hope that makes sense, because see, I have to find the first occurrence, right? So first, for finding the first occurrence, I will always have to go towards the left side, right? I cannot go towards the right side. I will do that if I have to find the last occurrence, right? Because the last occurrence will be towards the right and the first occurrence would be towards the left, right? So I will have to now apply binary search on the left half of the array, and that's why I'm doing R equal to mid minus 1, right? So that's what I will do. And now I will come out of this if statement and I will write an else if over here, that if my array of mid is not equal to target, then I will check if my array of mid is actually greater than target, right? And if it is greater than target, then obviously I will again have to apply binary search on the left half, right? Because my mid element is actually greater than target. So I have to reduce my mid now. I will have to move my mid towards the left, right, to get a smaller number. So that's why I will do R equal to mid minus 1. And if my array of mid, right, is actually greater than target, lesser than target, so that will go into the else condition. In that case, I will be doing binary search now on the right half of the array. So now I will do mid plus 1, L equal to mid plus 1, right? That's what I'm doing now. And this is how I will just figure out the first occurrence of the target. And if there is no target occurrence at all in this particular input array, there is, like, the target is not present at all in the array, then I will just come out of this while loop, and I will just return -1 over here like this, right? So that is my find first function, right? On a very similar note, I can also declare my find last function, right, to find the last occurrence. Now see, there are other ways of doing this, right? We can have multiple ways of applying binary search and solving this particular question, but I thought this is very intuitive to understand, and it will be very easy for you to grasp, right, what the intuition is behind this particular algo. So I think that's why I went for this particular approach. But if you can think of a different approach as well, while still using binary search to solve this particular question, just go ahead. There are like just multiple ways of doing this particular question, right? So now I will just declare another function, find last, right? And now what I will do is, the only change I have to do is I have to check whether my next element is not equal to target, right? Or my mid is itself the last element, right? If my current mid is the last element and I'm getting target over there in that current mid, that means that is the last occurrence of the target in the input array, right? And if that's not the case, then I'm checking if the next element next to the mid is not equal to target and the current element is of course the target, then of course this mid is the last occurrence again of the target, right? So that's why I'm just checking if my mid is equal to n-1 or my next element is not equal to target, right? In that case, I will return the mid. And if that is not the case, if it is not the last occurrence, then now I will just apply binary search on the right half of the array. And for that reason, I will just do L equal to mid plus 1, right? And rest of the things will stay the same. That they are like standard statements of a binary search algo. So nothing changes over there. If my array of mid is greater than target, then I will now apply binary search on the left half of the array. If my array of mid is lesser than target, then I will apply binary search on the right half of the array, right? And if this particular target is again not present at all in the input array, I'm going to return -1, right? That's all what I'm doing over here. And now what I can do is I can come back to my main function over here, right? After I have found the start index, right, of this particular target in the input array, now I can do a quick check if my start is actually equal to -1, right? So that would mean that, this target is not at all present in the input array. And in that case, I can just return 0, right? Because that is what is asked in the question, that if we don't don't find any occurrence of course the number of occurrence, right? Because see, if the target is not at all present in the input array, then obviously the number of times it occurs or the number of occurrences of this particular element in the input array would be 0, right? And that's why we will just return 0 over here, right? And if it is not equal to -1, that is, it is present in the input array at least once, then we will go on to find the last index as well, right? So I will just say last is equal to, and I will again call find last function now, right? Like this. I will just change this to find last, right? This will give me the last index, last occurrence. And now what I need to do is I just need to return last minus start plus 1, right? That's all what I need to do, and this will give me the number of occurrences of this target in this input array, right? So I hope this is very clear now. What I can also do is I can just increase the size over here so that it is clear, right? So that's how we can solve this particular question. And now I will see you in the next video. Thank you.